Other pseudo NMOS circuits. The bias voltage for pseudo NMOS circuits can be easily obtained using a reference circuit such as that shown in figure. The ratio of W by L1 to W by L2 should be the same as the ratio of W by L equivalent to W by LP. W by L equivalent equal to 1 by 2 W by LP is a reasonable choice as shown. The transistor Q3 has been included to realize capacitive loading, which helps minimize noise being injected onto V bias. Its exact size is dependent on how many gates the reference circuit is connected to and can be determined using spice level simulation. Alternative pseudo NMOS circuits can be realized that do not require a reference or bias circuit by simply connected to the gate of the P channel load to ground and as is shown in figure. Notice that the relative size of the N channel drive transistor relative to P channel load transistor is now different. To obtain reasonable gate threshold voltages and output low voltages, the typical choice is now to take W by L equivalent is equal to 2 into W by LP. The transfer curve of the inverter of figure obtained using spice is shown in figure. It is seen that the gate threshold voltage is 1.58 volts and the output low voltage is 0.17 volts. Both are reasonable values. Also note that the gain at the gate threshold voltage is minus 6.5, which is less than the pseudo NMOS gate when the P channel load is biased using the bias voltage. The reason for the lower gain is that when the gate output voltage is at the threshold voltage, the P channel load, the transistor is in the triode region and has a smaller drain source impedance, that is RDS, than when it is in the active or saturation region. The analysis for the gain at the gate source voltage is left as exercise for the interested reader. As you can see in this figure, a circuit that can be used to generate the bias voltage for pseudo NMOS gates. In this figure you can see alternative typical pseudo NMOS inverter in a 0.6 nm technology. As you can see in this figure, the transfer function of the pseudo NMOS inverter of figure obtained using spice. Here this is the output range, this is input range. In this figure, a typical NMOS depletion load inverter in a 0.6 nm technology. Thank you.